If we're going to stave off the worst impacts of climate change, we're going to have to break our dependency on greenhouse gas emitting energy sources like fossil fuels. But could a switch to more renewable sources like wind and solar power actually emit more of the most potent greenhouse gas there is? The gas in question is sulfur hexafluoride, or SF6, and as you might imagine, each molecule is made up of one sulfur atom and 6 fluorine atoms. If you're a geek like me who scours the internet for science memes, and I have reason to believe that you are, you may have seen some of the cool party tricks sulfur hexafluoride is used for. It's odorless, colorless, and heavier than air, so if you inhale it, it lowers your voice, sort of like bizarro helium. It's also not very reactive, and it can prevent fires since sulfur hexafluoride displaces the air that feeds the flames. These properties also make it useful for industrial applications, namely for preventing short circuits and fires in high-voltage electrical switches and circuit breakers. This type of safety equipment, also known as switchgear, is necessary to prevent serious accidents, and electric grids need more of them as we add more sources of energy. So, as we add more renewables, we're also upping our use of sulfur hexafluoride. One UK study found that their electric transmission and distribution systems are increasing the use of SF6 by 30 to 40 metric tons every year, and worldwide we're expecting to use 75% more of it by 2030. And therein lies the great irony. Sulfur hexafluoride is a fluorinated gas, a group of gases with high global warming potentials. And even among this group, SF6 is the most potent greenhouse gas of them all, with 23,500 times the warming potential of CO2. And the molecule is synthetic, so it isn't broken down or absorbed naturally, meaning it persists in the atmosphere for thousands of years. That all means that a little bit of SF6 can have a disproportionately big impact. Of course, it's not as though we're intentionally adding sulfur hexafluoride to the atmosphere, unless you're using it to make your voice deeper. But that doesn't mean it doesn't leak from its containers and into the environment, and when it does, it's hard to notice. Like I said, the gas is odorless and colorless. According to NOAA, the concentration of sulfur hexafluoride in our atmosphere has more than doubled in the past 2 decades. SF6 emissions in 2017 in Europe were the equivalent of adding 1.3 million cars to the road. So, should we be worried? Does the increase in sulfur hexafluoride make all our efforts to switch to renewables for naught? Thankfully, no. In 2017, SF6 leaks accounted for just 0.11% of the greenhouse gases emitted from the UK. Still, regulators and the electric industry are working to find alternatives. For medium voltage use cases, there are other materials that could take its place, but SF6 is still the go-to choice for high voltage applications because it's proven to work and it's cheap. Attempts to regulate it have been met with strong political opposition from companies that were unwilling to change. Still, some companies are finding ways to do without it. Siemens, for example, developed high voltage switchgear that is SF6 free. Scottish Power Renewables is building a wind farm that will use clean air and vacuum technology inside the turbines to eliminate the need for sulfur hexafluoride. But where it can't be eliminated, better handling, training, recycling, and leak containment is key. And the good news is, SF6 emissions have been dropping year over year even as electric grids use more of it. Alternative energy sources like wind and solar can finally move us away from environmentally damaging fossil fuels by cutting down on the CO2 we emit. As we work towards more climate-neutral power sources, it's important that the grid that transmits and distributes that power helps us achieve a sustainable future too. If you like this video, feel free to get in touch with us in the comments. And as always, thanks for watching, and we'll see you next time.